Okay, we got a couple of fairly basic problems here that are introducing related rates. So first of all, related rates are exactly that. It's two rates that are related to each other. For example, if we had an above ground pool that's kind of like a cylinder, yeah? Okay, and we're filling that pool up with water from some hose. The rate, the faster the water comes out of the hose, the faster the water is going to rise in the pool, right? In other words, the rate at which the water is coming out as the hose is related to the rate at which the water is rising in the pool. That's what we mean by related rates. Just two rates, they're often in applications, they're related to each other. So before we do more involved applications, let's just be able to understand some of the basics. The area of a circle is pi RT. Now let's say a circle is changing, it's getting bigger or smaller with time. In other words, we're taking the derivative with respect to time, yeah? And we want to know what is the rate at which the area is changing in terms of the rate at which the radius is changing. Well, we just take the time derivative of this equation, both sides of this equation. So the derivative of A with respect to time is the derivative of A with respect to time. Pi is a constant and the derivative of r squared is 2, so we get 2 pi r to the 1 times the derivative of r, but the derivative of r with respect to time is dr dt. This is our equation that relates the rate at which the area changes with the rate at which the radius changes. So the area is increasing, if it's increasing at a certain, if the radius is increasing at a certain rate, the radius of some circle is increasing, well, the rate at which the area will be increasing is going to be the rate at which the radius is increasing times the radius at a certain point in time times 2 pi. That's what this is saying. So now we just have an equation with x and y, and we're told that if the rate at which x is changing with respect to time is 2, when x is 1, what is find dy dt, right? So let's take the time derivative of this equation. The derivative of x squared with respect to time is 2x to the 1 times the derivative of x, but the derivative of x with respect to time is dx dt, minus the derivative of y with respect to time, well, that's dy dt, and the derivative of any constant is 0. So if I add dy dt to both sides, we get dy dt equals 2x times dx dt. So, why just plug it in? When x is 1, so we dy dt. When x is equal to 1, when x is equal to 1, is 2 times 1 times the rate at which x is changing, but we're told that that's equal to 2, and that product is equal to 4. So that's the rate at which y is changing with respect to time when x is 1. Now sometimes you might, let's say if we took the derivative of this and we had a y over here in addition to x and dx dt, what would we do? Well, we could just plug in 1 for x and find out what is y when x is 1. Yeah, so that's what all you got to do in cases like that.